Shikha, good morning.
Good morning, Gayatri. Greetings, MozCoders.
A huge warm welcome to all of you present here, our esteemed partners, our honorable speakers, and our wonderful friends.
We at MFC-VIT are so pleased to have you here with us today, kicking off the journey to the competitive coding event of a lifetime, MozCode.
Some fish love to swim upstream.
Some people love to overcome challenges.
Summarizes what MozCode provides an opportunity to challenge yourself.
So let's begin this 2-day journey towards MozCode with an introduction to the world of competitive coding that awaits us with surprises and various new things to explore, especially developing your interests and skills as a coder.
First of all, I would like to extend our deepest appreciation for all our trusted sponsors. The title sponsor being Capital Inc., along with Zulip, Youth Incorporated, Give My Certificate, SRM Kesilla, ISTE SRM NCR, and Geek for Geeks VIT Bhopal, without whom this event would not be possible.
Next, I would like to offer our gratitude for our speakers, Ms. Ridhi Shikha, Mr. Rajat Jain, Mr. Bipin Kalra, who all are proficient in their fields and who took precious time out of their busy days to guide and impart invaluable knowledge to our young coders, to use not only in this event, but also while moving forward in their lives.
Last, but not at all the least, I thank the inspired coders from all around the country who have decided to join us for this event and make it a huge success.
Taking the insight of our speakers and using it to improve your coding skills and excel in the coding rounds, I'm sure you will learn a lot in these 2 days.
Now, I implore all of you to fill yourself up with knowledge, try your hardest to win, and also remember to have a whole lot of fun.
So let's get this party started. All the best, guys.
We'll now be featuring a short presentation of a title sponsor, which will be done by Capital Inc.
Are you able to hear me?
Yes.
Yes, we can hear you.
So let's get this started. Wait a minute. Screen share. Actually, I joined a bit late, so
Yeah, no problem.
is my screen visible?
Not
No,
yet. Yeah,
yeah,
it
yeah,
is.
it's
It's
visible.
loading.
Okay, wait a minute. So yeah,
Yeah, it's visible.
let's start with it. So the Capital Inc. way, as we speak, our goal is to help corporate and private clients reach their financial goals. So our story is not that interesting, I would say, but it's kind of fun to start a new thing, right? So we are global in vision, but rooted in Indian values. So Capital Inc. is a well-diverse stock investment company based in India that offers one-stop investment solution in all kinds of stock trading. We believe in growing with our clients and creating a valuable relation, right? So yeah, thanks to a new algorithm and extensive market knowledge and innovative tools and dedicated client relations, Capital Inc. has become a principal interdealer broker with in both exotic and vanilla equity derivative instruments. So the problem that we were facing earlier was the adults the elderly mainly and the adults don't know much about stock market and are easily manipulated by random brokerages. And then as you can see that 95% of young adults don't even know how to buy a stock. So this is where we come in. So benefits of trading with us. So you'll get single access to all markets. It's a one-time payment. Then just wait for your returns. We do a deep quality research with a new algorithm and an expert team. Um, and we also provide a personalized customer support for all our users. So our heritage is that we believe in growing with our clients and creating valuable relations. We also offer advanced booking services across equity, derivative, currency, and commodity assets classes, and execution in cash and future equities. It's really a reality promise that Capitaling provides. We provide a single access to all markets. We have access to market segments of BSE, NSE, MCX, MSCI, NCDEX. So no need to worry where we will invest your hard-earned money. It's in safe hands, right? So we do deep quality research with a new algorithm and an expert team. We use comprehensive daily, weekly, and specialized research reports from expert sector analysis to make the most accurate report of the market by using a new powerful algorithm. The benefit that you'll get is that there's an expert team that also do the same work manually, just to verify and check if there is any possible way of losing your money or something. We believe in one-time payment and just wait and wait for your returns, right? Our team will take care of the rest. You just need to relax and enjoy your streaming service, or finish a book, or even take a long vacation in short. Don't worry. We give a personalized customer support. Reach out to us anytime, like literally anytime. We give personalized support from centralized help desk and through phone, email, live chat, SMS, and whatnot. So, finally, coming to our stock investment tips that we would like to give to you. Actually, it's 10 of them. So, but remember, trading is fun. Keep it that way. So, identify your stocks. Select the stocks that have ample liquidity, mid to high volatility, and group followers that allows for purchase or sale of large quantities without significant impact that the price, and can help grab any potential gain that may arise from large price movements on any given day. Build your own trading strategy. So this is important. Set rules that specify your entry, exit, and money management criteria for every purchase. The third one, keep a trading journal to record your wins and losses. Well, this is important. Why? Because with the stock market that is prone to frequent changes weekly and daily, it is very important to write to make a journal and make a record so that you can go through from the past experiences and past performances for any given thing. Avoid over trading. Trading only in a handful stock at a time is best way to go with your day trading. Avoid rumors. Always access and analyze how to piece a particular news that will affect the market, and only after that you should place your trade. Once volat- the volatil sorry the volatility dies down. So the sixth one, follow strict stop loss. Make it a habit to use stop loss, as it can prevent large and uncontrollable losses in volatile trades, and help that could potentially result in one's profit. The seventh one, choose business, not stocks. Simply trading in the most popular stock may seem like the way to go, but the best, but it is best to trade based on company's brand name rather than popular shares. It is always better to evaluate a company before you choose to trade its shares. Right. So the eighth one, choose business, not stocks. Why? Well, simple. Well, we have repeated that. Yeah. Stay up to date with the latest financial news and trading trends. This is important because intraday trading is not about punting markets, or it is a lot more about being organized, keeping a tab on news that helps in evaluating the flow of corporate actions and results in efficient trading. Understand that trading is not everyone's cup of tea, and this is the last point that we will discuss. Trading requires immense effort and time. Make sure you research as much as you can about the stocks before trading, and evaluate your weekly performance to ensure smooth trading. Thank you, and we also look forward to working with you. We'll give the rest details in the chat, and yeah. So
Yeah, thank you so much. Thank you so much, sir, for sharing such amazing experience and idea. We hope this would guide us, would guide many of us to handle the stock market. Okay, now I'll hand over the session to Yash to carry the session towards MozCode.
So, good morning, everyone. Uh, First of all, just go through the competition rules on our Discord server, and don't forget to register on HackerRank so that you can smoothly conduct the competition. Just read them out and go over the rules. So we hope that everybody is having a good time participating in MozCode. There are always a variety of methods to approach a certain problem. But if you follow plausible tips and techniques, that is the key to productive coding and problem solving. MFC-VIT is here to present you with such an incredible opportunity to learn from the best. Ridhi Shikha, SDE at Amazon, ex-Goldman Sachs, is here to share a brief introduction into data structures and competitive programming, which will improve your coding skills and become a better programmers. So, welcome, Miss Ridhi.
Um, Hi everyone, thanks for the introduction, Yash. I'll share my screen and we can get started with the presentation.
Yeah, sure.
Let me know if you can see it. Is it visible?
Yeah, it's visible.
Okay, cool. Just give me 1 minute. Sorry. Cool. So hi everyone. Thanks for the introduction, Yash. So as he said, I'm Ridhi, and I'm working in Amazon right now. I did my master's at USC, and as a master's student and as a software engineer, I have learned that having a good knowledge of data structures and participating in competitive programming has always helped me, my friends, and my colleagues in expanding our knowledge. It also helps, like understanding data structure also helps you a lot when you're looking for jobs, as most companies in the market assess candidates based on their algo and data structure skills. So, what are data structures? They are a fundamental part of computer science, and I'm sure as a computer science student, you must have heard of them quite a lot. They make problem solving in computer science fun, easy, and more efficient. And they also, as I already said, help in industry interviews as well. Now, what is competitive programming? Competitive programming is also known as sports programming. Basically, you're given a problem statement with input test cases that you're required to solve, and your solution is then evaluated based on multiple factors like time, space, complexity, runtime, your how clean your code is, etc. A lot of companies also sponsor such events and give you job offers based on your performance, like they give job offers to the top competing candidates. So I hope everyone's following now. So this is the main part of the presentation, which is top data structures for competitive coding. So let's talk about the top few data structures that beginners to competitive coding should know and practice. The first one is stack. So a stack is a linear data structure where the order in which operations are performed is last in, first out, or first in, last out. How this can be explained is, consider stack as a stack of plates. So you go to a wedding and you have a bunch of plates stacked near the food. What is the plate that you pick up to eat food from? It's the first plate out of the stack, right? That plate might have been the last plate that went in because the first plate that went in the stack is at the bottom. So that's how stack works. The last element in is the first element that comes out of the stack. Now, as you can see in the picture, there's like 3 operations that stack actually supports. The first one is push, where you push an element into the stack. It's the top of the stack. The second option is pop, where you remove the newest item from the stack, which is like taking a plate and eating food with it. So you're taking a plate, you're popping. When you're putting a plate back on the stack, that's like pushing. And then there's top, which just gives you the value of the newest item. So for example, think of it as the stack of plates at the wedding, like just visualize it, has a number written on it. So each plate has a number written on it. So the first plate at that stack has number 5 written on it. You just want to see what number that plate represents. So you'll just check it out. You'll basically take out the first plate, see what number is written on it, and that's it. You're not removing anything. So that is top. So that's difference between pop and top. Pop just removes the item. Top gives you the value of the item. It's very easy to implement a stack using an array. Now I want this session to be a bit interactive. So I'll ask the audience a question. And I might keep asking questions in the middle, so just keep listening. So my first question is, how would you find the number of items in a stack? Just give me your answers and then see. Yash, if you could read the answers. Keep popping until empty and count the popped items. Yeah, that's a very good answer. So you can keep popping and have a counter and then do a count plus plus each time an item is popped. And at the end of it, when you reach 0 and there's no more items available, then you know the number of items in the stack. Exactly. The other option is the position of the top pointer. So you can have, like, for example, if let's see X index is the top. When you do a top, you know the index, and then you can find the index of that value, and that index plus 1 will be the total length of the stack. Yeah. So position of top pointer plus 1. Yeah. Cool. Those are very good answers. So I guess I don't need to explain it further. Thanks everyone. So this is a basic implementation of stack. So you can have a large enough array S and have a counter K which starts at 0. So for example, if K is equal to 0 right now, you push value 5, for example, in the stack. So the value at S0 is 5. And then you increment K by 1. So now the value of K is 1 and S0 is 5, right? If you add any other value, for example, after 5 you add 6, then the value of K would be 2 and the value at the top would be 6. To decrement a stack, you don't actually need to remove anything. You can just decrement the value of K. So if the value of K is now from 1 to 0, 6 is automatically removed because the next time you insert something in the stack, the value at the first position will automatically be replaced. I hope I'm clear. If you have any questions, please give them in the comments and I'll answer those. And then there's stop, which just returns the value. So it's an index search. You just like find out what's the value in S of 1 and then you just find it. Most of the languages like Java, Python, C++ have already have implementations of stack, which you can directly use. But you should be able to implement it from scratch by using an array. So I would suggest everyone to try that once. Just like cool. So the next important data structure is queue. Queue is again a linear structure, and the operation that it performs is in the order of first in, first out. So the first thing in is the first thing that comes out. You can think of it as a line. So think of like you're going to a bank and there's a long line. The first person in the line is the first person that will talk to the bank officer, right? That's how it works. So that is what a queue is. So in queue, as you can see here, it's kind of like stack, just the implementation is a little different. So here in the queue, there's three operations that can be done. There's enqueue, dequeue, and front. In enqueue, you insert a value to the queue. So again, when you're inserting a value to the queue, think of it as a line in a bank. When a new person enters, they won't enter at the start of the queue. They'll enter at the last position of the queue, right? So adding a person at the back of the line is enqueue. DQ is removing a person from the first of the line. So the banker is ready to see the first person, that is DQ. That person then goes ahead, DQs, and the line continues moving forward. Front is just, for example, the person in the front has like a sheet of paper that has 5 written on it. You just want to know what that person is carrying. So that's front. So you know that person is carrying something 5. That's the value that the person is carrying. That's front. You're not removing the person. You're just finding out what the person is carrying with them. So that is how like queue works. So as it's written in the slide itself, the difference between stack and queue is just removing. In stack, we remove the item which was at the top. In queue, we remove the item that was least recently added. And in stack, we remove the item that was like added most recently, because in stack, you add at the top. Is this confusing? Does anyone have any questions? Okay, moving on. So this is like a basic implementation of a queue. You assume that the total number of elements, like you know that how many elements will enter the queue. Now you have two indices, head and tail. In stack, you just had one. So head is at the top of the queue and tail is at the last position of the queue. And then you can use these two to dequeue. So in dequeue, you'll just increment the head. So that means that that value of the head is gone and then you increment the head by 1. So if the 0th position was already gone, you increment the value of the head to 1. I'm explaining this in an array kind of way. For NQ, you increment the tail. So you added, like in the 5th position, you added someone. So now from 4, the last position of the queue is 5. And you can again use the value of the tail to check the emptiness. So like the tail value is the last position of the queue, right? So if there's 0 items in the queue, the value of the tail will be 0. So you know that there's nothing in the queue. So that's how you know it's empty. Again, you can use queue and queue in like C++ and Java already has predefined ways in which you can use it. But then you should do a queue implementation by scratch as well to understand the data structure more properly. Next is linked list. So the linked list is also a linear data structure.
Sorry to interrupt you, but there is a question, right? Where is the queue implementation mainly used? Like,
so I guess queue implementation, there's a lot of questions where queue implementation is mainly used, but let me think about it. I'll answer that question at the end of it, maybe. Because it's been, I don't think it's used a lot, but give me 1 second. It's mainly used in like CPU scheduling and algorithms, like a lot of those. Also, there's a deadlock or like read-write operations that are going on, and then you use queues in that so that you have like a proper queue implementation. Yeah, IRCTC. Okay, yeah, sure. And also like booking tickets on an airline and stuff. Okay. Thanks everyone for answering that question as well. Cool. So moving on to linked list. As I was saying, linked list is a linear data structure where elements are stored in such a way that each element has 2 parts in it. The first part is the stored value, and the second part is the pointer to the next element. So over here, the head has the address of the first element. So the head has the address 3200, which is the first address of the first element. Now that element contains 2 things. The first thing is the value, which is stored in that element, which is 15. It's the content of the element. The second thing is the address to the next node, which is 3600, which you can see, as you can see, is the address of the next node, which again has a value and a pointer. This goes on until the end of the linked list, which actually just has the value and does not have any pointer to the next node. So the last node points to null. So in simple words, a linked list consists of nodes where each node contains a data field and a reference link to the next node in the list. You can think of the practical example of a linked list as a scavenger hunt. So you have a clue, and that clue has the pointer to the place to find the next clue. So you go to the next place, and then you get a piece of data and another pointer to the next place where you can find the next clue. So this keeps on going. And the only way to get something or get to the end is to start from the beginning and find all the clues to reach the destination. So that's how a linked list works in practical situations, basically. Okay. Next data structure is a binary tree data structure. So a binary tree is where each tree, like each node has can have at most 2 children. So it can have 0, 1, or 2 children. So that's a binary tree. The first element of a binary tree is called a root node. So over here, 1 is the root node. And then it can have max 2 pointers, right? So as I already told in linked list, for example, a linked list has 1 pointer, which is to the next element. In a binary tree, there are 2 pointers. The first pointer is to the left child, and the second pointer is to the right child. So the left child of 1 here is 2, and the right child is 3. So 1 contains a value and 2 pointers. 1 to the left child, 1 to the right child. And then at the end, when you see like there's like no more children, so 8, 9, 10, 11, 13, and 14, those are leaf nodes. Leaf nodes are the last nodes which do not have any children. Okay. So binary search tree is a node-based binary tree data structure which has some specific properties. So the left tree of the node contains node which is lesser than the node's key, and the right subtree contains the nodes which are greater than the node tree. So I can explain it more further in this example. So imagine that you have a list of numbers and you have to basically form a binary search tree out of it. So what you can do is, if you get 8, once you get 8, you put 8 as the root node. The next value that you get is 3. Now you'll check, is 3 less than 8 or greater than 8? Since 3 is less than 8, that will be the left child of 8, which will be the left subtree. So 3 is in the left subtree. Then comes 10. 10 is the right child of 8 because 10 is greater than 8. So, and this actually goes recursively. So for example, if you got 6, 6 is less than 8. So it goes down. And then 6 is also greater than 3. So it becomes the right child of 3. And that's how it keeps going until all of the numbers are traversed in here. And they are assigned a value. Does anyone have any questions right now? I'll move on. So the next example of a data structure is heap. Now heap is a special tree-based data structure. So it's a complete binary tree. Can anyone tell me what a complete binary tree means? Okay. I can tell you what it means. So a complete binary tree means that all the nodes have 2 children unless they are leaf nodes. So basically, every node is complete. When you say it's complete, it means it has 2 children, not 0, not 1, unless they're leaf nodes. Leaf nodes will not have any children. So it's like a complete binary. That's what a complete binary tree is. Now heaps are complete binary trees which have specific characteristics as well. So a heap can be a max heap or a min heap. A max heap is where the root node has the maximum value out of all the children, all the nodes. A min heap is where the root node has the minimum value among all its children and all the nodes. So to explain that further, you can see this heap data structure. So as you can see in the min heap, so if you want to find the minimum value in a min heap, you just have to check the top of it, like the root node of it. It's 10, and you know that, yeah, 10 is the minimum value. So this is this data structure is very helpful also when you have to find the, for example, n top n maximum numbers or top n minimum numbers. You can just be like, it's 10, then it's 15. And you can traverse through the heap and find out the maximum or minimum numbers like that. So in min heap, as you can see, 10 is maximum. And then again, you have 15 and 30 after that, which are like the next minimum. So then 15 is next minimum, 30 is next minimum, and it goes on like that. And in the max heap, 100 is the maximum. So you just have to have one constant operation. That is, you just have to find out the top of min heap to find the minimum value, and top of max heap to find the maximum value of amongst a number of, like if you're given a list of numbers. Okay. I hope everyone is with me till now. Um, so the next data structure is priority queue.
Ma'am, there is a question from Prakash, like, uh, do we need to be an expert in recursion understand tree and BST?
No, you don't need to be an expert in recursion. A lot of time trees are created using pre-order, in-order, or post-order traversals. So you can just have an array and then organize that array based on those traversals, and then you can just create a tree like that.
Okay.
Okay. So next is priority queue. So priority queue is an extension of a queue. So in real life example, you can think of it as the VIPs, the so-called VIPs or the VIP lines, or in airport security, there's like a VIP line. So there's a normal line and there's a VIP line. In the VIP line, there's each person has a priority assigned to them. And then the person with higher priority is basically processed or helped first. So in a priority queue, the same thing happens. Each element has a priority assigned to it, and everything is dequeued based on the priority. So the high priority person or element will be helped first or dequeued first than the low priority element. Now, if two elements have the same priority, then they will be served according to their order in the queue, which is the same as first in, first out. So as you can see, there's an example that I've provided here. So in this priority queue, the priority is based on the ASCII value of the element. So we've inserted C, then O, then D. Then it's remove max. So when you're removing the max, which is like the maximum priority, O has the maximum priority as it has the higher ASCII value. So it's removed then. So that's how a priority queue works. So basically the typical operations are insert. So you always insert an item with its priority. You have get highest priority, which can be easily found by DQ. And then delete highest priority, you just remove that item. You can easily implement it using array or heap because queues can be implemented using arrays. But heap is generally a better option. Why? Because it's easier for performance as we already know what the highest value is. So basically, as I explained in heap right now, you can use max heap for priority queues. So the maximum priority value can be the root node. And you can organize the heap according to the priorities assigned to the elements. So the heap implementation is basically faster because it has a constant time operation that can be performed to find the highest priority queue for getting the highest priority or deleting the highest priority.
Ma'am, there is a question from Kunal saying that that he has understood the concepts of pointers but have a lot of trouble in its implementation. So how can he overcome it?
So so pointers are basically if you have problems in understanding pointer, I think the only way that you can solve that problem is by practicing a lot. So a pointer basically has the address of the like it stores the address instead of storing the value, right? And pointers are very important in a lot of data structures like linked list, like trees that I explained, and then again trees, heaps are also trees. So I would say to overcome it, just try solving a bunch of questions which are pointer based. You'll find like a lot of programming questions which use pointers. Also try making a just try clearing your basic knowledge of pointers first. Like try using C because C is like an easier language to learn for pointers. Java doesn't use pointers as much. So try implementing them from scratch. Try implementing linked list without you from scratch. Try implementing a tree structure with from scratch, and then I think you'll be very confident about pointers. I remember I had done that because when I was in undergrad and I was studying about all of this. Pointers was a subject which was kind of like hard to understand for a lot of people. So the more you practice, the more you learn. That's what my suggestion would be. Also, try asking your friends if someone has the better knowledge to help you out. And there's a lot of online portals as well that you can use to understand algorithms and the implementations. I have those in the slide as well.
Yeah, thank you, ma'am, for answering that.
Cool. So the next data structure that I'm going to talk about is graph. So as I said before, that all the data structures I was talking about were linear data structures. Graph is a non-linear data structure. It consists of nodes and edges. So the main difference between linear and non-linear data structure is that in linear data structure, everything is sequential. And in nonlinear data structure, you arrange data based on relationships that the data has between its elements. So in the graph, the vertices have relationship with each other. And when I say vertices, I mean all the nodes are vertices. And then there's edges, which are the connections between two vertices. So the nodes are referred as vertices. The edges are the lines or the arcs. Graph is used to solve a lot of real-time problems. And graphs are also used to represent networks. So in networks, it may include paths for like between city, like paths in a city or telephone network or a circuit network. Graphs are also used in social networks like LinkedIn, Facebook. For example, in Facebook, each person can be represented as a vertex or a node, and each node is then has connections between with other nodes, which are like basically your friends in Facebook, right? And also in graphs, like each node can also contain information. So it's not like it just has connections; it also has a value associated to it, which is 0. So over here, the node, for example, in Facebook, the node can have your name, your gender, your date of birth, your location, etc. So that's how a graph structure generally works. Any questions? But graphs are a lot of times used in like for BFS, DFS as well, like breadth first and depth first search. When you want to find, like when you want to search something. Next data structure is a hash table.
Man, there is a question like, no matter what data structure I study, I feel linked list is quite disturbing.
Uh, Yeah, so linked list is like one of the basic data structures, and once you get a hold of that, you can learn any data structure. So I would say try practicing linked list based questions. So I had links after like at the end of the slide, but I would say try LeetCode, try HackerRank, and try some of the linked list based questions, which are like maybe just removing an item from the linked list. Like how do you do that, or how do you search through a linked list? Just try solving those questions. Try just creating a linked list from scratch on your own on your local dev desktop, and then try performing different operations, linked list operations on it, and that would help you. For example, for removing a linked list, you know that linked list has a value. Someone has like a favorite, okay, but imagine linked list has a value and an address to it, right? How do you remove an item from the linked list? You just start pointing the linked list to another element, and automatically the element in the middle is removed. So try doing those things in linked list. Try going crazy with linked list, and I'm pretty sure it will help. Okay, so the next one is hash table. So this is a very important data structure because this is used a lot. It always solves the complexity problem. It's very fast retrieval. So what is hashing? Hashing is a technique where you map keys and values into a hash table by using a hash function, and it gives you a faster access to the element. Now, a hash function is a function that converts a huge number into small integer values, and then that is mapped as an index. So I'll just give you a basic example so that you can understand this very well. For example, let's see there's a hash function x mod 10, right? And then you have a list of values 11, 12, 13, 14, and you want to store them. So where will you store 11? The hash function says that is x mod 10. So 11 mod 10 is 1. So you store 11 at index 1, right? 12 at 2, 13 at 3, 14 at 4, and so on. Now, when you want to find or search for an element in the array, generally what you do is that you traverse through the array. You go through the array and you're like, oh, is this 11? No. Is this 11? No. Is this 11? No. And that's how you find it. But if you're using a hash table, you can just see the element, apply the hash function to it, and you'll know the position at which that element is. So that makes the data retrieval much easier and faster. So basically with hashing, you get a constant search time on average. which is O of 1, and then O of n in the worst case, where you have to go through the entire array. But hash table has this one important thing that you have to think about, which is the hash function, the efficiency of the hash function. So in the previous example, there's 11, 12, 13, 14, and 15. So in this type of value in this type of an input value, x mod 10 will work. But what if one of the values was 21? Then x mod 10 won't work, because even for 21, x mod 10 will give you index of 1. So you can't use this hash function then, because it will give you kind of like a hit. So like you will have two values which will have the same index. So you can't use that hash function anymore. So the efficiency of hash function is very important. So you have to come up with a hash function which is unique enough that all of your data points that you have can be accommodated into it. Hashing is a solution which is most commonly used. You'll see them used in a lot of solutions in competitive coding. We use hash table a lot. It's a very good data structure to solve problems, and it is very time efficient. Now, there are many more data structures, and I would not go into all of it because I don't want to burn you all out. I would just suggest you guys going and taking a look at it. There's Huffman tree, there's Union Find, there's tries, and so on. So I would just suggest you guys to go and take a look at all of the data structures, and I'm pretty sure that you'll also learn about them through your professors. But I think practice is the key. So like you can go on geeks.geeks, Coursera, AlgoExpert, and a lot of different websites where you can learn more about data structures. But again, as everyone is asking, how do I solve the problem of like, how do I understand a linked list? And the best way to resolve that problem is by practicing. So try implementing each data structure that I've talked about right now on your own from scratch, instead of using a predefined hash function, just a hash map. Try creating your own hash map. Try creating your own hash function. Try creating your own tree or your own linked list or your own stack and queue implementation. And you don't have to use that every time you solve a problem. Just do it so that you understand how to implement them, because that basically clears up your knowledge on how they are being used. And then you can easily just use the already implemented stack queues that are provided in most of the languages or linked list, and then use it directly. So that is something that I would want you all to take from this session.
Ma'am, there is a question from Kunal that which data structures are mostly used in industries like Amazon and big giant companies?
I would say the data structure we use the most is a hash map.
Okay.
Also graphs, I guess. Yeah. Okay. So
Any more questions? Any more questions? Anyone?
okay, if there are no other questions, I'll go forward. So now I talked about the data structures, right? And I talked about competitive coding. How do you find out that your solution is better than the other person's solution in competitive coding? So that is where time and space complexity comes. So it depends. So complexity depends on the time taken by your solution and the amount of space your solution takes, right? So the complexity is basically the efficiency of the algorithm. There are two main complexity measures that are used: time and space complexity. There are various ways of solving a problem, right? And the best solutions always take time and space complexity into account. Time complexity is basically a simple measurement of how fast the time taken by a program grows as the input increases. Space complexity is how much amount of memory space is required to solve that problem with the size of input. And these two things are always taken into account based like when you solve a problem. So anyone can solve a programming question, right? You can use an array with a lot of loops and solve it, or you can use a hash map. So your time and space complexity is what matters at the end of it, when you are competing for such any position or like any competitive coding challenge. And one of the notations that is mostly used is big O notation. So I'm pretty sure you will learn this soon, or you might have learned this. There's a lot of notations, but big O is basically a measure which is kind of like the average, which gives the average of your solutions time space complexity. So this is a function which gives the average. So you can use that to find what space and time complexity is. But I think it's the max. I'm kind of I'll if anyone knows, just like type that out. But yeah, it's the most it's the notation that is used the most to calculate the time and space complexity of your solution. So now that you know a lot about data structures, I would suggest to get coding and start practicing them on your own. I have listed a bunch of websites that I used a lot. So the topmost is LeetCode. It has really good questions, and it has questions marked as easy, hard, medium, all of that. It has a lot of questions which were actually asked on interviews and asked during coding challenges of major companies like Facebook, Google, Amazon, Microsoft, etc. There's also HackerRank, HackerEarth, Top Coder, CodeChef. So I would say start from any one of them, try solving easy questions, and then go forward with like medium hard questions. I think most of the companies mostly ask hard or easy questions. Medium or easy questions. Hard questions are very few which are asked like sometimes in coding interviews. Mostly they are asked in coding challenges, which are like basically hack challenges where you're given questions and you have to solve them, and there's like a prize associated with it. So here are some of the very popular programming competitions. So as I said that a lot of times such competitions have sponsors, which are companies that actually give you a job offer, like to the top contestants in these competitions. So these are like a few competitions that you guys should look up once you've started competitive coding. Google Code Jam is something that I would suggest highly. There's like Facebook Hacker Cup, ACM, ICPC. So you should try these competitions. Cool. So that's it. I hope I did not overburden you with knowledge, because that's the one thing I did not want to do. So I try to keep the slides simple. Thank you so much for attending this session with me, and I hope that I gave you some useful information, and I'm open for questions.
Yes, man, there are a few questions like your experience with Amazon and preparations for it.
Okay. So I would say, so first I was an intern in Goldman Sachs, summer intern 2019. So for that, and then I gave the Amazon assessment as well. Most of the competitions, like for most of these assessments, I use LeetCode to practice, because LeetCode has like a bunch of solutions, and most of the questions are from it. I'm not being biased towards the site, but that's the site that I use. It also has solutions. It also has algorithms, like different algorithms. So there's different complexities that you can use to solve such questions. So yeah, in my experience with Amazon, I think I've learned a lot. The one thing that I learned a lot is native AWS services like S3, Lambda, how to use it, how to like that. They are basically computational services that make your task easier, and they are used a lot in Amazon. What are the
Yeah,
challenges?
man, the second question, yes, ma'am. The challenges that you faced in competitive coding.
So the biggest challenge is to not be disheartened if you're not able to solve a question. It's okay to look at the solution and understand how to solve that problem, and then try it on your own. So once you understand how to solve it, then try coding it on your own instead of just like copy pasting the code. So you know the solution to it, but you're just trying to resolve it on. It's kind of like an algorithm, right? You know the algorithm, you are then implementing it. So you can take in the beginning, you can just take it like that. Look at if you're not able to solve a question, or if you're not able to solve all the test cases, look at the good solutions that are out there and try implementing it on your own. And slowly you'll just progress, and you'll be able to come up with solutions on your own then, because most of them, once you get the hang of it, you'll be able to solve most of them.
Ma'am, your experience in data structures.
um, so I so the data structures I discussed right now are the basic data structures, right? There's also like others that I talked about. There's also different algorithms that are come up. There's dynamic programming, which is used, or the knapsack problem that is used a lot. So data structures, like I would say, take it as the most important course in your computer science curriculum. Data structures and programming. Basically, you can just learn one programming language and you'll be able to program in any language because all of them have a basic structure that they follow, any object oriented language. But data structures are something that you need to know, which help you a lot, first in understanding how to solve a problem, and second, in your hireability. The more you know about data structures, the more you're able to implement them, the more you are hireable.
Mm. Yes, thank you, ma'am, for answering that. Second question is like uh, from Nishchay Jain that he likes development, but while doing DSA and competitive coding, he feels bored. So, what should you suggest him?
So, can you tell me why you feel good? Is it because like of the reason that I told before that like you are like, oh, it's hard to solve this, and then you look at the solution, you understand it, and then you don't try to implement it on your own, or is it more because like you're able to solve all of them? And if that's the case, then it's brilliant. You don't need to solve any more questions. But if you feel bored because you just look at the solution like, oh, this is how it's done, I would say try solving it on your own again. Even if you look at the solution, just try solving it on your own, at least once.
How to balance like in competitive coding and development?
So to be honest, competitive coding is more like to see your skills, like your data structure skills and your computer science, like how good you are at implementing or solving a problem. In development, you don't use that a lot, to be honest. It's more clean code. It's more how much you can solve a particular question. Most of the data structures that I have used are like mostly hash map. And that's like I saw a answer which was like hash map makes life easy. That is true. But yeah, like basically the main reason that the companies check your data structure skill is because they want to see how good you are at problem solving. If you're given a problem, are you able to think in different ways? So one suggestion that I would give, especially for people who are like in a position where someone is interviewing them and they are solving it on a whiteboard or they're solving it online on the site, always think out loud. If first, no one expects you to come up with the perfect optimal solution in the first go. You might come up with array first, right? You might have a loop solution first where you have like a bunch of for loops, and then the person would ask you, okay, that's good, you solved the question. Now, can you make it better? Can you make it in such a way that it's more time, it's like time complexity is less? So then you can come up with another solution, which is like, oh, if you use this algorithm, then actually it's faster and it's more like it's consuming less space. So we want to, like most of the recruiters, they want to know your thought process. So don't just be like, don't just think for 10 minutes and not say anything. You can start with like, hey, I'll have like I is equal to 1 and I'll do it like this. Just talk through your process. Whatever you're thinking, just tell them what you're thinking. So in that way, they know that first you can solve a problem. Second, you can also come up with different solutions to a problem. Okay.
Yes, ma'am. Another question is what should we give priority to, like developing skills or coding skills?
What do you mean by developing various skills? Like,
Like web development, app development, and
so web development, app development is something which is like, for me, I think anyone can do that. Like you just have to go on Stack Overflow mainly. You'll get like most of the code and you can just develop an app directly. Um, I would say making your data structure skills like strong is better. But yeah, like it's good to have side projects, right? So I don't know if I know which one is better. I would say they go hand in hand. Like even during app development, you can use your data structure skills, right? So that you implement it like faster. Your app is like instead of clicking and waiting, like your app is like waiting a long time to load the data. You have implemented some great data structure skill, which makes it much faster to retrieve the data, right? So both of those things can go hand in hand.
Uh, Ma'am, can you please share something about your college days with respect to coding and uh,
Okay. So I would say like I can talk about my masters more, which was recent. Um, we had the algorithms class, which was the first year when we had the algorithm class where we had to learn all the data structures. And then we also had a web tech class, which was web technology, where we had to create a website. We had to create an app related to the website where you would have add to the cart and everything. And for most of my friends and all of us, data structures and algorithms class was harder than the app development class. Because, yeah, app development class gave us a lot of practical knowledge. We had a lot of projects on our resume. But algorithms class made us think in a critical way on how we are solving a problem. So yeah, those things. I think having some projects on your resume, try getting internships, which also like allow you to have some projects. Basically, having projects shows you that you are an independent worker, and you have like that drive in you that you're trying to learn more. Data structures is mainly about the core fundamental CS skills that you have.
okay, ma'am. Uh, so I'm picking the last question for the day, like from Akshat Gupta. Like he says, if I'm a front-end developer applying for a job as the same, then why do they tend to ask DXA question in interviews? Why don't they stick with the questions related to the development stack?
Yeah, so I can give you a straightforward answer to that. Most of the coding like scripts that we have, they can be like they are being automated, right? Most of the code can be directly like you can have automated injection of code, right? Most of the things are not logical that you're thinking logically about like this is how I should come up with the front end stack or whatever the UI stack. Um, they want to know that I think someone also answered that they want to know how good of a problem solver you are, like how good you are at handling edge cases, how good you are at something which like some unexpected problem comes up and how good you are at solving that. So that is what I would say that is what it helps with. Yeah, if you say that why do they ask aptitude questions and why do they ask I don't know, other questions, yeah, that is irrelevant. But I think data structures is very important because it shows how you can come up with different approaches to a particular problem. And also, like at Amazon, there's one thing that we have a lot is design reviews. So before going through a project, you actually create an entire design of how the backend will look like, how it will interact with other services, and how the front end will like how it will interact with other services. And these type of design diagrams, when you have them, and when we have design discussions, we have a bunch of approaches, recommended approach, and a bunch of other approaches that you saw. Yeah, they are not very basic like linked. I'm using linked list or I'm using queue. They are more like, am I going to create a lambda and have an SNS um, notification to it, or am I just gonna query through a database? But all of these things come, like all of these different problem solving solutions come to you when you actually have proper knowledge of how data structures and how different problem solving solutions work. So I would just say it helps in understanding how good of a problem solver you are and how much you have learned.
Mm, yes, ma'am. Thank you for answering that question, ma'am. There's another question from Prakash that he's scared of recursion. So, how to get better at it?
Hmm. Again, I would say if you want to get better at recursion, try creating recursive functions and try just creating a bunch of recursive functions calling each other. And then try adding like a bunch of print statements to it and see how each one is calling the other one, how recursion is actually working. Like have one function and have a recursive function and have that function call a recursive function. Then recursive function will just keep calling itself, right? And have like a print statement in it, which is like step and then I'm at step and then just have a counter n, which is just incrementing based on how many times that recursive function has been called. And you can just keep doing that. Just try implementing, try using recursion in solving a bunch of problems. And yeah, like I think that will help. If you have like a question which is like, I think the very basic question is asterisk, you have 1 2 3 4, right? And sometimes you just create a loop, like I is equal to 1 and then 4 and I plus plus, and you just print out 1 asterisk, 2 asterisk, 3 asterisk, 4 asterisk. Try solving that using recursion and see what happens.
Yes, ma'am. Thank you for answering that question, ma'am. So, since there are no more questions, uh, on behalf of all the members of Mozilla Firefox Club and attendees of the webinar, we sincerely express our gratitude towards Ms. Ridhi Shikha for her words of guidance, which we hope answers some of the participants' questions regarding competitive coding and provides them with a better picture of MozCode. Her words have encouraged us to code with passion and provide a direction to our curious mind. It was a pleasure to have you, Ms. Ridhi. Thank you very much.
So I also had shared my LinkedIn profile link in the chat. So if you guys want, you can also like follow me on LinkedIn. If you have any questions, as I know there's some questions about internships, you can connect with me and I'll help you out. Thank you.
Thank you, ma'am.
Bye. Thanks, Yash.
Yeah, welcome, ma'am. So coming to the Morse code part, I would like to repeat the rules for the competition. Make sure that you have registered on our website with same HackerRank username with which you have participated in all rounds. If not, then we won't be able to contact you for further details. Round 1 will be of 2 hours starting from 3 p.m. Indian Standard Time, and contest will end at 5 p.m. Top 50 participants will get qualified for round 2, and the participants will be ranked by scores. And if two or more participants achieve the same score, then the tie broken is by the sum of first correct submission for all the problems will be considered. Thank you for connecting with us. Have a nice day. All the best for the competition.